Hello, class. That's what we're doing today, classify numbers. Class. Black, like my glasses, by the way? Okay. All right. Oh, I just closed that. Why is that open? That's supposed to be closed. Discard. There we go. It was slowing down the recording. Okay. So the first thing I'm going to have to do is hit share screen. And I'll show you what we're going to do today. Share entire screen. It'll be quick and easy and painless. I'm going to keep that up here in the corner. So today, classifying numbers, we did this last Wednesday, and so it's a short review. It's going to be on the test. Try to do all this stuff on your own before you look at the answer key. I'm going to make answers right now live on this video. I will post this video, but you'll also have a copy of this document with the answers. Download this document blank and see if you can do the problems. All right, so we're going to talk about, let me shrink down so you can see the whole thing. This is what would be called a Venn diagram. A Venn diagram could be about all kinds of things. We could be looking at, school lunches and where they come from and that kind of stuff. This is about number sets, okay? We started out with the smallest set down here on the bottom, natural and counting numbers. And notice it is a smaller set and it is inside of whole numbers. So whole numbers includes all natural counting numbers. But not every whole number is inside this set. That's why this one's bigger. And integers is bigger than whole numbers. It has all whole numbers and all natural counting numbers in it, but it also has something extra. The opposite of whole numbers, negative numbers, okay? And then rational numbers is the biggest. Okay, so and then we'll talk about irrational for a moment, okay? So let me just zoom in, and I'm just gonna jot down a couple notes on each one so you can see examples of what numbers go where. Now when we want to draw, let's pick a color that stands out. Okay, so natural counting numbers is like using your fingers and toes, okay? No zero, no fist. Just, how old are you, little guy? I'm 2. Where they can't even talk, they just hold up fingers. So that would be like 1, 2, 3, ... When we put the ... dots, that means it goes on forever, all right? Now, whole numbers include all natural and counting numbers, but it also has the whole, the donut hole, the zero. The zero shows up for the first time, okay? So 0, 1, 2, 3, ... It includes all whole numbers, but it also has the zero, which whole numbers do not, or which natural numbers do not, okay? The next number set is integers. So the mathematical definition of integers I will say throughout the school year, every time we say integers, just to remind you. Integers are all whole numbers and their opposites. Opposite seems like everybody knows what that means. It's technically a vocabulary word. So if it's 2, the opposite is -2. If I say -7, the opposite of that is 7. So integers are all whole numbers and their opposites. Now, one true or false trick question they sometimes throw out there is, what is the opposite of 0? Well, mathematically, technically, there is no opposite of 0. That seems kind of logical, right? So when it says whole numbers and all their opposites, there is no opposite of 0, just to clarify. Way to write it would be like -2, -1, but before the -2, I gotta have my dots, because it goes on forever in the negative direction, okay? 0, 1, ... and it goes on forever in the positive direction, okay? One way to try to help you remember integers, okay? The beginning of the word sounds like the letter N, so you could think of negative, negative, okay? That's where negatives first show up, okay? Only a certain type of negatives. We'll talk about that in a second. Okay, so integers are the whole numbers and their opposites, which are negatives. Now, in class, in every class, and you all had, from every class, had a few people answer, what are some types of numbers we use in everyday life that you don't see represented here? Integers isn't the biggest number set. It does not include everything. And many people were able to say, yeah, like fractions and like decimals. So if I had 75 cents, because in money we use decimals too. So those are 2 other big types of numbers we use, and we're going to call them logical or rational numbers. Like if a 1 and a 2 exists, obviously, on any kind of ruler made in the world, whether there's 3 marks between those two numbers or 25 marks between those two numbers, there is a halfway point. So you could have 1.5, okay? And the decimal representation of that would be 0.5, okay? So that's important to know. That's its own number set, rational numbers. Now it does still include everything else. Everything else is still inside rational numbers. That's the big set, okay? So it includes 1, 2, 3, ... It includes 0, and it includes these negatives, but it also has decimals and fractions. Here's the trick they try to get you, and it's usually one of the first or second option on test questions. They'll put like, if they want to be real tricky, guys, they'll do that. And they'll hope, and I don't think they're really trying to mess with you, but they're trying to be specific. You either know this or you don't, okay? See, a lot of people say, well, that's a negative. Negatives show up with integers. Well, no, integers do have negatives, but it's only the opposites of the whole numbers. So a 17 and a negative 17, a million and a negative million, no halves, no fractions. So even though this is a negative right here, it's got a decimal, so it shows up in rationals. But they might try to think, hey, some people, because I put 3 decimal places behind that, maybe they'll think that decimal is a comma, and they'll put it as an integer as negative 10,512. So make sure you be careful reading the commas versus the periods, okay? It makes a big difference, just like in English class. Okay, now the last section is called irrational. Now, you are not required on any benchmark or STAR test in 6th and 7th grade to know the irrational numbers, but we do work with some irrational numbers throughout the year. We will get them as answers sometimes, so we might as well include them on a chart so you know where they go, okay? So the first one of those would be that symbol, which means pi, P-I. Pi is, some of you knew the song, 3.14, and I'll put a squiggly line with an arrow, going on forever, no repeating, no patterns. It just continually changes the order and goes on forever, okay? Seriously, forever. That does not compute, that's complex, that's hard to understand, okay? One other kind of situation that could show up here, I'm going to write over here and remind you that when some of you learned this last year, what's that called, that symbol? That means the square root of 4. That symbol is called, I believe, the radical sign. It's been a year since I said it. Square root of 4, what they're asking you is, what times itself equals 4? You know your multiplication chart. Oh, 2 times 2 equals 4. So the answer is 2, okay? In the same way we could do 25, square root of 25. You know 5 times 5 equals 25, okay? Well, those aren't irrational. We can figure those out. And if they ever give you square root, oh, I didn't say that earlier. So I'm glad I did this one more time, because they do this to you on test questions. If they have the square root of 4 and they say place it where it goes on the chart, is the square root of 4 going to go with irrational numbers? No, because they talk about it like it's not simplified, okay? You can finish that. The square root of 4 is not done. Do it. It's like if they said 10 over 5. You don't leave it like that. 5 goes into 10 twice, so it's really the same thing as 2. The square root of 4 is 2. So they would want you to say, oh, okay, the square root of 4 is 2. 2 first shows up in natural numbers. And if they said, what all number sets does the square root of 4 belong to? Well, it belongs to natural counting. It belongs to whole numbers. It's the number 2. It belongs to integers, because it would be showing up right here. And it belongs to rational numbers. Rational numbers has all of it. Where the square root of 4 would not go is irrational, because it's solvable. We can solve that. It's a 2, okay? But what does go here in irrational would be the square root of like 2, or the square root of 7. What times itself equals 2? And every year there's somebody jumps out before they think, they blurt out 1. That's 1 plus 1. 1 times 1 equals 1. Anything times 1 equals itself. 3 times 1 equals 3. Okay? So can you multiply anything by itself to get 2? No, it's going to be some repeating forever number like 1 point, I don't even know. Okay? And it's not 1.50 times itself. That I can't remember if that equals 25 or 625, something like that. So 1.5 times 1.5 does not equal 2. Okay, therefore there is no exact square root. It's a hard, almost near impossible to calculate and going on forever situation. Okay, so if you see a square root and it's not a number you know from your multiplication table, like maybe if it said square root, one more, if they said the square root of 121, most of you learned your multiplication table up to 12. That's 11 times 11 is 121. Okay, so 121 would just go right here. Square, or I mean, it equal 11 once I solved it. But I could write the square root of 121 there because when you solve it, it's 11. Okay? And last one. Some of you may be familiar with this already, but there's a number of fractions that do repeat forever. If you shoot and make one basket out of 3 shots in a game, or if you get 1 hit in an at-bat in a baseball game out of 3 at-bats, or you get 1 ace out of 3 serves, etc. If your stat is 1 divided by 3, that's really saying 1 divided by 3. 3 goes into 1 0 times. You drop the 0 there. 3 goes into 10 3 times because it's 9. Well, there's going to be 1 left over. I'm going to drop a 0 again. Oh, I'm going to have 10 again. So it's going to go 3 times again. So 9 minus 9 is 1 left. Oh, it's going to be 3 again. Goes on forever. So that would be 0.3 repeating bar. Okay, bar notation. So if you get something with the repeating bar that goes on forever, it's a rational number, including if it had a pattern. It doesn't have to just be 0.3 repeating. You could have a 2-digit number repeating, okay? Sorry, it's a little sloppy. We're done with that page. Okay, mix and match vocabulary. Try to match these. Read the instruction. 2 of these letter answers or one of these letter answers will be used twice, okay? The only other thing is this should have been C, this should have been D, this should have been E, this should have been F. I mislabeled them, okay? So notice the letter B takes up 2 lines. That's why you can see it looks like they end at the same point, so I have one for every single line, but because this takes up 2, we're missing one, okay? Pause now, come back and I'll go through it real quick. Okay, we're back. I usually don't like to read irrational numbers and then go sorting through all of these. And then every time you pick a vocabulary word, you're reading all the definitions over and over, looking. Start with the definition right here on letter A and go find where it fits. Using your fingers to count. 1, 2, 3. That was like the basic one at the very beginning, right? Oh, I see it right there, natural numbers. So I'm going to write A. I'll zoom in a little bit, guys. Sorry. So I can write better. This is kind of small. Okay, so A is done. B, first includes positive and negative fractions and decimals. Well, guys, we just did that. Fraction and decimals are in the biggest number set, the rational numbers. So B is going to be down here. D, or what should have been C, all the sets we have learned are in this set. I don't know if I said that very quickly, but real numbers. Real numbers is the whole thing, guys, okay? All right, real numbers. Let's move along. Okay, back to the vocab. So all the sets we have learned are in this one set. That's real numbers, D. E includes 0 for the first time. The whole is the whole numbers. That is E. Okay? All whole numbers and their opposites. Oh, that's the one right above whole numbers until you remember what it is. Their opposites will be negative numbers. Negative numbers first occur in integers. So F is right here on integers, okay? And the last one, G, the symbol for pi, the square root of 2, and other complex, nearly uncalculatable numbers. That is irrational numbers, G. Well, G, Mr. Douglas, I have one left over. Well, that's why it said 2 of these will be used twice. So natural numbers is the same as counting numbers. It's going to be the same answer, A. And using your fingers to count, 1, 2, 3, okay? All right. Here's a few words just to mention briefly. You can write your own version in there. I mentioned Venn diagram. It's any kind of picture diagram where you're highlighting or conveying relationships, things that are grouped together, things that are subsets of each other, things like that, okay? So we used a Venn diagram to display all the classifying numbers. If I said, what is this picture? And you said Venn diagram, I could say, okay, yes, it is a Venn diagram, but what is this Venn diagram showing? It's the real number sets, okay? So set is a group of things together, like the numbers, like integers is a set. A subset is inside of another set. So integers is a subset inside of rational numbers, okay? Real numbers are not a subset. It's not a part of any other larger number set. Real numbers is everything, okay? Whoa. I somehow leaned back and made the glasses disappear and then came back, okay. Terminating decimal. So if you did 1 divided by 2, it equals 0.5. Not 0.51234 going on forever, or 0.5555. It terminates, it ends. That's what terminate means. The decimal stops, okay? A non-terminating decimal would be like the 0.3 repeating. 0.33333333333 forever, okay? Which then we get to this, the repeating bar. A lot of people call it repeating bar. Its technical math vocabulary is bar notation. So we'll know what you mean if you say repeating bar, 0.3 with the repeating bar over it, okay, 0.3 repeating. All right, and last thing you're gonna do, I've got 7 numbers for you to put here onto the number set. Wait, listen to one instruction. Put them where they show up first. Don't put them in every set they belong to, because like the number 1 goes in all the sets except irrational, okay? So you guys pause, try to put them in their places, and then I'll show you the answers in a second. This is the last thing. Okay, we're back. Classifying numbers, right? Put the following numbers in their proper set where they show up first. So a lot of times on tests and things, they would put something like this first to try to throw you off. Oh, negatives, they go to integers. But look, it's got a decimal. So make sure you don't miss out on that. All decimals and fractions, positive or negative, are rational. Hey, just notice, if you guys see, it looks like I have an earthquake and it's shaking like that. I'm writing on my laptop with my finger. This is got that feature, so when I write, a lot of times it makes it bounce, so I'll try to hold it. Okay, so that takes care of negative 7.5. 1 million, big giant number. So I would get people put that in rational and integers and think, oh, that's a really big number, so it's got to go in a bigger number set. Now look, natural counting numbers are 1, 2, 3, ... That ... means it goes on forever, to a million and beyond, to a billion, to a trillion, okay? So the 1 million, the 1 M there, goes in natural numbers. 0, where does it show up first? The donut hole, right there. Okay? Negative 12. Okay, now that's the negative. There's no decimal or fraction. Integers, N for negatives. So negative 12 is here, okay? I got a fraction, 3/4. The last set is that has all the fractions and decimals, positive and negative, okay? Pi, oh, you just told us that, sir. So pi, Pi, stands for this math symbol, means pi. And anytime we use pi in class, we usually just round it through. Sorry, I messed that up. To 3.14. Let me see, I just want to see if this works. Yeah. Well, what I did is I just drug, let me see if I can do it like this. I just drug the picture. Oh, back arrow. Whew, don't panic, kids. Just hit the back arrow and it'll undo whatever stupid things you did. Okay, so we're all back. Okay. So pi 3.14, and it repeats forever, but we will usually just, if we're doing stuff on our calculator, we'll just use 3.14. Okay. Where to leave off? So that's pi, and then the last one. .3 repeating. That means it's going to have the repeating bar like that. I just said that's logical to us. We can understand it's just going to be 3 forever. Okay. That's it, guys. There it is. So this, you'll have this posted as your answer key, and you'll be able to try to do it yourself. Let me see if I can remember to close down properly, stop sharing. And I'm still recording. So guys, see you in class tomorrow. Make sure you try to do all the homework for classifying numbers. It's going to be on the test. We want to be the best class on the test. We want to be #1. Work hard. Thank you very much.